Okay, so in the last video, I explained how get die counts works. So now I'm going to explain place in three of a kind. Now remember, the game has called I believe it's the place dice method. Where is it? It's called, the game has called place dice and given the player an array of dice. And then the guy using the program, he clicked on the screen in some category. Okay? So in mouse pressed, all dice was not equal to null, it didn't quit. He clicked in an appropriate category, so it wasn't outside of his column. And let's say that it wasn't in the upper, but it was it was not in the upper section, but in the lower section. And let's say that he clicked in the three of a kind category. So the place in three of a kind method gets called. So place in three of a kind. Let's assume that this is the first time he's ever clicked in the place of three of a kind category. So when we initialize a player, his three of a kind variable is initialized to -1. This first line of code, it says if this.three of a kind is not equal to -1, return. So what this does is if he's already clicked in that category and scored it, then it's going to be, it won't be equal to -1. If it's not equal to -1, he's just going to quit. Okay? That prevents the player from scoring the same category multiple times, right? So assuming that it is equal to -1, if it is equal to -1, then it won't return. It's going to get the die counts. So now it's going to create a Boolean, a flag. It says, hey, I've got a three of a kind. It starts it out as false. And then it's going to loop through these arrays looking for something that is 3 or more. So for int I equals 1, I less than 7, I plus plus, if die count sub I is greater than or equal to 3, set three of a kind equal to true. So by the time we get through this loop, if any of these were 3 or bigger, then got three of a kind is going to be equal to true. So now we can say if we've got a three of a kind, then our score for three of a kind should be equal to the total of all dice. Otherwise, our score for three of a kind is equal to 0. So if they click in that category and they don't have three of a kind, they get 0 points for that category. Once it's set to a 0, they cannot click in it ever again. That makes that 0 score permanent for that category. But if they did have three of a kind, their score for that category is the total of all dice. So we just total up the dice. We've got a method for that. And then we say end turn. So if they successfully click in the category and the category is not full, that ends their turn. So if we did not quit up here, then we will end up executing the end turn, which releases the dice, tells the game that, hey, we've placed the dice successfully, and to repaint. Okay? So when we tell the game that we've placed the dice successfully, what does the game do? It says, hey, the dice were placed. We'll go ahead and reset all the dice, enable the roll button. It says current player equals this dot whose turn. What I want to do is I want to store for later whose turn it was before I increment to the next player. So I say, okay, well, let's just go to the next player and say it's the next player's turn. And then if whose turn is equal to the number of players. So say I've got 6 players. the index of the last player is going to be 5 because the first player has index 0. So if we've gone off the end beyond the last player, then go back to the first player. This is what causes a cycle. This allows us to cycle through the players. So increment to the next player. If we've gone past the last player, go back to the first player. And then as long as the current player is not whose turn, as long as the player whose turn it is now is not equal to the current player, the player whose turn it was before we started, we want to be careful because at this point we're going to skip players whose scorecard is full. This is a little bit complicated. So, all players sub whose turn scorecard is full. So let's say we've incremented to the next player, and that player's scorecard is full. Okay? If a player's scorecard is full, we want to go on to the next player. And we want to keep on going on to the next player until we get to a player whose scorecard is not full. And so that's why we make it a while loop and not an if statement. We just keep on incrementing to the next player, whose turn plus plus, and then checking to see if the scorecard is full. But we've got to consider a couple of other things. Each time we increment to the next player, we've got to make sure we haven't gone past the end of the players, okay? So these two lines of code are exactly like these two lines of code. Just go to the next player and make sure that we haven't gone off the end. But there's one other case to consider. Not only do we have to keep going until we have an empty scorecard, but we want to be careful because if we get all the way back to the player who just finished, that means all the players might have full scorecards, okay? So there are two ways to get out of this loop. Either we found a player whose scorecard is empty, or we've gone all the way back to the first player where we started. So now if the person who we're now at has a full scorecard, then we couldn't have exited because the scorecard was not empty. We must have exited because we got all the way back to the first one, and the first one's scorecard is full. So everybody's scorecard is full, so we set the game over equals true and disable the roll button. Regardless of any of this, whenever we change the person whose turn it is, we want to set the roll count to 1. So this dice placed is fairly complicated, but it's essentially the player has told the game that he has successfully placed the dice, and now the game is going to find the next player with a scorecard that is not full. And if he's gone through every player and they've all got full scorecards, he's going to set the end of game to true. So we've got place 3 of a kind. We've talked about end turn. End turn is going to be used multiple times. We've talked about get die counts. That's going to be used in other functions. So the idea for your place in 4 of a kind that you have to write is going to be just like place in 3 of a kind. So you're going to have to do a check to make sure that the 4 of a kind is not equal to -1. Make sure that you don't just copy paste the code and forget to modify the things that you've got to modify. You're going to need to get the die counts. You're going to need to loop through and find out whether they've got a 4 of a kind. And so it's not going to be get 3 of a kind. It's not going to be get greater than or equal to 3, but maybe greater than or equal to 4. And then if they've got a 4 of a kind, you want to set the score to the total of all the dice. Otherwise, give them a 0. and then you'll want to end the turn. So it's very similar, but a couple of really little changes from the place in 3 of a kind to make place in 4 of a kind work. Full house, similar. If full house is not -1, quit. Go ahead and get the die counts, but for a full house you need to have a pair, so we've got a got 2, and you need to also have a 3 of a kind, so you've got 3. You go through all of the counts, 1 through 6, and if the count is equal to 2, you've got 2. If the count is equal to 3, you've got 3. Now this, I've got a bug here. This should be equal to 5. Now if you've got, this is kind of a silly thing, but if they had rolled 5 2s, that is also considered a full house. So you're not going to have exactly equal to 3 or exactly equal to 2. You've got 1 that's equal to 5. Of course, that's a Yahtzee, and if they clicked in full house when they had a Yahtzee, they're not a very good player. But we should go ahead and say got 2 and got 3 are also both true if they had a Yahtzee and they clicked in full house. Go ahead and give them the full house. So once you get out of the loop, if they've got a pair and they've got a 3 of a kind, go ahead and set the full house score to 25, because that's how many points a full house is worth. Otherwise, if they did not have both a pair and a 3 of a kind, set full house equal to 0 and end the turn. Small straight. Small straight is similar in some regards. It's just a little bit different. If small straight is not -1, if they've already scored it, just go ahead and quit. Then get the die counts. Now this count equals 0. This is the how many in a row, right? So this is walking through the array of counts, and as soon as it's found a certain number of consecutive non-zero elements, if that row of consecutive non-zero elements is at least 4, then they've got a small straight. So you start out by saying, I'm going to assume that they don't, and then I'm going to walk through all the die counts. If the die count is not equal to 0, count plus plus. So what does that look like? So let's assume that I'm going through this example, and these are my counts: 0, 2, 0, 1, 1, 1. So the first time through this loop, I'm going to look at index 1, and it is equal to 0, so I'm not going to increment my count. Count is still 0, so it's not equal to 3, and then I come around to the next one, and I say die count sub 2. Since die count sub 2 is not equal to 0, my count goes up to 1. But count is still not equal to 3, so I do not yet have a small straight. So then I go to the next one, and I say, is die count sub 3 not equal to 0? Well, it is a 0. So it's not going to do the if, it's going to do the else. It's going to set your count back to 0. So the count was 0, the count went up to 1, and then it goes back down to 0. Never reached 3. And then it's going to go to the next die, which is the 4th die. Here your count is not equal to 0, so it's going to go back, my count is going to go back to 1. But 1 is not equal to 3, so I still haven't seen a small straight. And then it's going to go to die count sub 5. Die count sub 5 is not 0, so my count goes up from 1 to 2. So 2 is not equal to 3, so it still doesn't see a small straight. And then it goes to the last die, die 6. Die 6 is not equal to 0. So count now goes up from 2 to 3. It sees that the count is equal to 3, so it says that it's got a small straight. I've got a mistake in my code. See, a small straight is a sequence of 4. It sees this sequence of 3 and is treating that as a small straight. So my code should expect a sequence of 4, not 3. So let's look at another example and see what happens. So this one should have a small straight because I've got a 1, 2, 3, and a 4. Okay? So the first time through the loop, the count goes up from 0 to 1. The next time through the loop, the count goes from 1 to 2. The next time through the loop, it goes from 2 to 3. The next time through the loop, it goes from 3 to 4. It sees that the count is equal to 4, so it says, hey, got small straight is true. It'll still go through the loop again, and now it sees a 0, so it'll set the count back to 0. And then the next time through, it sets it back to 0 again. But it doesn't matter. Once it has seen a small straight, got small straight remains true. Let's look at another one. Here, the first time through the loop, the count starts out at 0 and it stays 0. The next time through the loop, the count goes up to 1 because we've seen something that's not 0. The next time through, the count goes up to 2 because we've seen another thing that's not 0. The next time through the loop, the count goes up to 3 because we've seen something that's not 0. The next time through the loop, the count goes up to 4 because we've seen this fourth element that is not 0. That's 4 consecutive elements that are non-zero. It sees that the count is equal to 4, so it says, hey, I've got a small straight. It'll go ahead and go through the loop again and set the count back to 0. But by this time, got small straight is already equal to true. So this time, my small straight is a 2, 3, 4, and 5. Let's go through example 4. So with example 4, the first time through the loop, the count goes up to 1. The next time it goes back to 0. It didn't reach 4. The next time through the loop, it's set to 0 again. The next time through the loop, it's set to 0 again. The next time through the loop, it's set to 0 again. And the last time through the loop, it goes from 0 to 1. So there was not a consecutive sequence of 4 non-zero elements. It did not see a small straight, so it does not set the small straight to true. How about this one? The first time through the loop, the count is 0. Second time through the loop, the count stays at 0. The third time through the loop, count goes up to 1. The next time through the loop, it goes up to 2. The next time through the loop, it goes up to 3. And then the last time through the loop, it goes back to 0. We had a sequence of 3, so it got up to 3, but we'd need a sequence of 4 to have a small straight. I got to check my rules. Is a sequence of 3 or is a sequence of 4? No, a sequence of 4 is a small straight. So sequence of 3 doesn't count. We have a 3, 4, 5, but we don't have a sequence of 4. Here, count is 0, count goes up to 1, count goes up to 2, count goes up to 3, count goes back to 0, count stays at 0, it never reached 4. We had a 2, 3, 4, but we didn't have a sequence of 4 needed for a small straight. So you get out of the loop, and if you had a small straight, this got small straight variable was set to true. So if we've got a small straight, then the score for small straight is set equal to 30. Otherwise, we set it to 0. But if we didn't return up here, we have to end the term. Large straight is going to be similar to small straight, but you're looking for a sequence of 5 instead of a sequence of 4. Placing Yahtzee is a lot like 3 and 4 of a kind. How am I doing on the... Oh, this video is too long. We're going to do Yahtzee and upper section in the next video.